Welcome to the fascinating world of optical telescopes, where we explore how these incredible instruments extend our human vision beyond the stars. Our human eyes have limitations in resolution and sensitivity, and atmospheric distortion further hinders our view. Telescopes overcome these biological and atmospheric limits, allowing us to see the universe more clearly. A telescope is an instrument designed to collect light, improving clarity and detail, and making faint objects visible. It's important to note that telescopes are not just magnifiers, they reveal the unseen. Telescopes perform three basic functions: light collection, image formation, and image detection. These functions work together to provide a clearer view of the cosmos. The larger the aperture of a telescope, the more light it can collect, making faint stars visible. Think of it as a large bucket collecting rain compared to a small cup. Telescopes have the ability to separate close objects and reveal details invisible to the human eye, much like comparing a large bucket to a small cup in terms of capacity. Telescopes have the ability to separate close objects and reveal details invisible to the human eye, much like comparing a large bucket to a small cup in terms of capacity. Refracting telescopes use lenses to focus light, playing a significant role in the history of astronomy. Early telescopes, like those used by Galileo, paved the way for modern discoveries. Refracting telescopes face challenges such as chromatic aberration, heavy and expensive construction, and impracticality in supporting large lenses. Reflecting telescopes, invented by Isaac Newton, use mirrors instead of lenses. Modern telescopes often employ this design for its efficiency and effectiveness. Modern telescopes use mirrors to avoid chromatic aberration and are easier to build and support. Multiple mirrors can create a single, large mirror for enhanced observation. Reflecting telescopes come in various types, such as Newtonian, Cassegrain, and Dobsonian, all utilizing mirrors to collect and focus light. Ground-based optical telescopes are located on Earth's surface, capturing visible light but are affected by atmospheric conditions. Observatories like Keck and ESO are prime examples. Space-based optical telescopes, like the Hubble Space Telescope, are located in space to avoid atmospheric effects, capturing images with great clarity. Ground-based telescopes are affected by atmospheric turbulence, while space-based telescopes avoid these distortions, providing clearer images. Optical telescopes can observe a variety of celestial objects, including planets, stars, galaxies, and nebulae, expanding our understanding of the universe. Telescopes gather and focus light to see distant objects, with reflecting telescopes using mirrors for efficiency. Space telescopes capture clearer images by avoiding Earth's atmosphere. As we bridge forward, we explore non-optical astronomy, including radio and infrared telescopes.